Hello and welcome guys. Welcome to my YouTube channel. Today we are going to solve one of the lead code problem. It is of a easy label. Let's quickly jump to the description of the problem. So given the root of a binary tree, return the sum of every tree nodes tilt. So we have to return the sum of every tree nodes tilt. And what is tilt? The tilt of a tree node is the absolute difference between the sum of all the left subtree node values and all the right subtree node values. If the node does not have a left child, then the sum of the left subtree node values is treated as 0, and the rule is similar if the node does not have a right child. So what it is simply telling, if it is a leaf node, there would not be any left subtree and there would not be any right subtree, and you can consider as 0. So that's why 0 minus 0 would be 0. So for every leaf node, I mean that would be the case, right? So if you see this example for 2, left subtree is 0, right subtree is 0, so that's why the difference is 0. For 3 as well, same. For 1 we have to calculate, so 2 minus 3, absolute difference is 1, and if we sum all the tilt values it will become 1. Now take this example. So here also 3, 5, 7, these are the leaf nodes, so we can say that the tilt value for these will be obviously 0, right? Now let's calculate for the 2. For the 2, the tilt value will be 3 minus 5, which is equal to 2, because 3 minus 5 and absolute difference is 2. For 9, if we have to calculate, the left value is 0 and the right value is 7. So 0 minus 7 will become 7 if you are taking the absolute. Now for 4, right? This is very important to understand. When we are calculating for 4, we have to sum all the left subtree and we have to calculate all the right subtree, and then we have to find the absolute difference. So 3 plus 2 plus 5 minus 9 plus 7, which is 6, and then use sum all the tilt values for every node which you have found. The value will become 15. I hope you have understood the problem. So the way in this problem, only two important points you have to think is how you can find the left tree node first and then the right tree node first, right? Because once you are able to identify this problem, this part, then it's become very easy. Because if you are able to reach to the left and right, and then you can calculate the absolute difference, right, from these two nodes. And when you are calculating, that value would be for the root node, right? So for 2, these tilt value is 3 minus 5. For 3, if we have to calculate, the value would be 0 minus 0, because the left subtree is 0 and the right subtree is 0. So for 3, the tilt value would be 0, right? So how should we traverse a tree first? So in this case, if you see, we need to know the left and we need to know the right? And then we want to calculate, right? So which traversal algorithm you want to use? So if you have seen post order, right? So there what happens? First you go left and then you go right, and then you calculate the tilt value, right? So for the leaf node, it's very simple, because we can simply say that, okay, just return 0 and that's our answer for the leaf nodes. So, but if I have to calculate this particular node value, right, for 2 here. So I want to go first left and I want to go first right, and then you know then I want to calculate my absolute difference between these and these two, and then I want to return that value to my root, right? Because that would be that would be my answer for the two, right? Okay, so but if you consider this part, the second point which I'm talking about, if you see this 4, right? So for 4 we have to return the sum of the complete left subarray. So um, when I am at 3, so my tilt value is 0. For 5 it is 0. For 2 is 5 minus 3, right? But when for 4 I have to calculate, I have to first return this whole sum, right? So if you see, right, I am going to return always the sum of, from my function, right? I have to return the sum of left, right, and the node, right? Because uh, okay, so how the DFS is going to work, let me just explain a little bit here. So for 3, this is 0, this is 0. I'm just adding a 0, 0 here for our understanding, right? So what is the 3 left value? That is 0. What is the right subtree value? That is 0. That's why three's value is, um, you know, um, I mean, we can store and we can say that tilt value is 0. Same would be happening for 5. For 2, when we are calculating, we can actually return the sum of these 3, right? So 3 plus 0, that is 3. So this will return 3. And here what will happen? This will also return 5, 0 plus 0, this will return 5, right? And then for 2, what we can, you know, calculate the tilt value is 3 minus 5 is 2. So we can store somewhere, right? When we have to calculate for 4, what we have to return from my function? I should return this plus this, right? 5 plus 2 plus 3. It should go here 10, right? That's how I'm going to, implement this function. So the 2 point important is what you are going to return from the function, and the other is which traversal technique you are going to use, right? So, and I need one variable, right? Let's quickly actually write the code. So, because we have to, return, I mean, as an answer, we have to return the complete sum. So let me just say that there is an answer, and I will create one array of one size because I have to use inside a function as a reference. Initially, that value would be 0. Let me just call this function as dfs, and the root is there, right? So what I'm saying, if root is none, right, then return 0, because if leaf node is there, then we know that the answer would be 0, right? And the dfs, we can call first left, and then we can call right. So this is our post order traversal algorithm, right? So once we have identified our left and right node, right, let's store it in some variable. Let's say I'm storing into my left variable, I'm storing into my right variable. Okay, let me align it properly. So, so let's say this function is able to return my left and right value, right, properly. Then what I have to do simply is, let's calculate it, right, for every node. Uh, Answer is there. What I can do is left minus right. Okay. Now, here is the important part. From this function, right, what I'm going to return. So as I explained is, when we are returning is, we have to return left plus right plus root dot value. So let me explain it again because this is very important and this is confusing as well, right? How this particular thing is going to work. So once we are, calling this function, it is able to reach here, right? We are able to reach at this point. Now, when we are going for next thing, it will return 0 because there is no left. When we'll go for right, this will also, there is no node, so this will also return 0. So for 3, what I'm saying, I will calculate, right? So my left is returned as 0, my right is 0. So for 3, right, I'm calculating 0 minus 0 is 0. That is first time I will be calculated for 3, right? Now in the recursion tree, what will happen? It will start calculating for the 5. For 5 also it will see left is 0, right is 0, right? So again, my left value and right value will become 0, 0. So 0 minus 0 is 0. So for 5 also it will be 0. So we have calculated for 3 and we have calculated for 5, right? So obviously if you see, this is my left recursion, this is my right, and somewhere for the node we are calculating, right? So for 3 I calculated, for 5 I calculated, right? That's how the recursion is working because it is coming here, it is coming here, then it is going here. First it is calculating this one. Once 5 and 3 is calculated, recursion will go to this, right? 2, and for 2 we'll try to calculate. So what I should return in my function? So what I'm saying is, when I'm when I want for my left, right, my left return should be 3 plus 0 and 0. So if it is not making sense, let me just remove all these things and just think about this, that if you are at a 4, right, your left subtree should return you 3 plus 2 plus 5, isn't it? This should be returned. And for right, it should return you the right subtree. So just assume here it is 0, right? So 9 plus 7, it has to return. Okay. So that's why for once I'm able to find the left and right for a node, I am calculating that the difference. But for the next label of a node, right, I have to return. So when I'm saying for next label, so let's say I am able to calculate this part, and for the next label of this root, right, I have to return what? Sum of all these three, right? So one time it will return for the left, one time it will return for the right. But in the function, I have to return the sum of all the three. And that's how it will be working. So I hope you have understood this problem, and let's try to see if that is working. So I have to call this function, right? And I have to return the answer. Let me submit it. Yeah. So that's all for this problem, guys. If you have any question or suggestion, please let me know in the comment box. Let's see you in the next problem. Thank you.